So again, if we take a look back at that document that is under, so it's called, again, Connecting Application-Centric Infrastructure to Outside Layer 2 and Layer 3 Networks. And then down under the ACI Layer 2 connection to the outside fabric. And then that table here that's comparing the applications or the config variations, it's extending the EPG versus extending the bridge domain. Okay, in this next example, we're going to be extending the EPG. So we're not configuring it as a layer 2 out, which you could do. You basically have either option. There's a question here, can we see the MAC address of the gateway on 7K3? So hopefully it should be that 1234 address. If we look at the show IP ARP, okay, which it is. Okay, so that was essentially the Anycast MAC address that I had set of the default gateway. Okay, if we go to the APIC and look at show run, it's going to have an interface bridge domain 1001, and then that's an IP address configured on the link. Okay, the bridge domain from a behavioral point of view, it essentially is the VLAN. But the reason that they're taking the distinction between the bridge domains and the VLANs is that the encapsulation numbers don't necessarily have to match, which unfortunately makes it a little bit kind of overly confusing. So normally on like a catalyst switch, we would say interface VLAN 1. In the case of the ACI, what it is saying is interface bridge domain. And then instead of saying interface bridge domain VLAN 1001, we're using whatever name that we're calling it. Okay, but ultimately this configuration is the exact same thing as you would be doing on standalone NXOS. Instead of just saying interface VLAN 1001, we're saying interface bridge domain and then whatever keyword that we're giving it. Now, difference then would be on standalone NXOS, it's always binding VLAN 1001 as the access tag or the trunk tag that's going down to the southbound devices. In the case of the ACI, we can change that number around, and then as long as we're mapping the endpoint group to that bridge domain, that's ultimately what is doing the classification. Okay, it's no longer the VLAN or VXLAN number, it's the EPG mapping to the BD, to the bridge domain, that we ultimately care about. Okay, so next thing that we're going to do is, if we look back at the diagram, we're going to go to, let's say 7K1. And on 7K1, we're going to create interface VLAN 1001. Okay, this guy's going to be IP address of 10.0.1.71/24. Okay, so these guys are going to be in the same subnet. So on 7K1, in global config, we're going to create the VLAN. We're going to create interface VLAN 1001. IP address is 10.0.1.71/24. No shot. Okay, then we have the link to the leaf. If we look back at the diagram, this is port 1/7 from the 7K's point of view, and 1/7 is going to 101 on leaf 101. So on 7K1, we're going to configure this as a normal trunk port. On leaf 101, we're going to attach the EPG onto the link, and then we're going to extend the bridge domain out in this direction. Okay, so on 7K1, we're going to go to interface E17 it was. We'll say this is a switch port. The switch port mode is trunk, and no shot. Okay, if we look at the show LLDP neighbors, we see we have the connectivity to the leaf. If we look at the show CDP neighbors, notice that we see the output for the leaf in the LLDP output, but not the CDP output. What this is telling me is that my access ports policy group is not yet applied to this particular link. Okay, if it was, since I was calling the interface policy, which was CDP on, we would see them in both entries. Okay, again, it's not really affecting connectivity, it's just kind of. Okay, so next thing we're going to do is we're going to go back to the Fabric tab because we need to initialize the interface. So we're going to go under Fabric and then Access Policies. Then under Fabric Access Policies, under Quick Start, we're going to configure an interface port channel or virtual port channel. Okay, under Leaf 101, this is our switch profile. We're going to add a new switch interface. So if you can see there, it's grayed out, but it basically means it's pre-configured, which is switch node 101. And then the profile's name is called leaf 101 underscore profile, which is the variable that we had created. Okay, the actual switch, this was part of the fabric discovery that I had given it node identifier 101. So under node 101, we're configuring one of the interfaces of that device. And this is going to be port 1/1. Okay, the interface selector, it's calling it by default switch 101 underscore 1 dash ports dash 1. I'm going to call this interface selector leaf 101. Okay, to make the config a little bit cleaner so we know that it's corresponding to that particular box. And then under interface policy group, we're calling the same policy group that was already created. Okay, it is access ports policy. Okay, save the config and then submit. If we go back to 7K1 and look at the show CDP neighbors, we now see that we see the leaf. Okay, this tells us that the interface policy was properly created. If we go back to the APIC and look at the show run, we should be at the same state as we were previously with the link to 7K3, where we have the policy group applied to the interface, but we don't actually have the application or the encapsulation applied to the interface because the EPG has not yet been deployed. So if we scroll up a little bit under leaf 101, we have interface E1/1 that has interface policy group access ports policy, but it doesn't say switchboard access VLAN or switchboard trunk allowed list. Okay, now this next step is going to be one of the caveats of the system. I'm not sure if this is fixed in the newer releases. Okay, in this example, we're running release 1.3. I don't know if it's fixed in the newest one, which is currently 2.2. Where we'll look at the fault and then I'll talk about what the issue is. But there's going to be kind of a quirky behavior of the ACI leaf here. Okay, so what we're going to do is now go to, and actually let's go to 7K1 as well. Or actually, no, 7K3. We're going to ping to 10.0171. Okay, count unlimited. That's the destination we're trying to reach. Okay, so we're now going to go back under tenants. Under tenant INE, then under application profiles, the application EPG, we're going to deploy the EPG on an interface. Okay, so the endpoint group is already created. What we're now doing is just adding it to another link. Okay, the port that we're applying it on is going to be leaf 101, port 1/1. The port encapsulation is VLAN-1001. Okay, that's the segment that we're trying to extend outside of the fabric. Okay, we're going to apply the config right now, and we're trying to trunk that VLAN. Okay, so we're sending it with a .1Q tag. Okay, it says validation failed. Validation failed for the VLAN-1001. FV mode should be either set tagged or untagged on all ports of distinguished name 0 equals UNI, INE, INE apps, EPG public web servers. Okay, this is the limitation that I was talking about here, and unfortunately this error message is not very intuitive. What this is telling us is that there is some sort of hardware limitation of the box, or software limitation, I'm not really sure which one it is, but it's a limitation of the box, that you can either tag or untag the VLAN on the leaf, but not both at the same time. So on leaf 101, if we think about this from a physical point of view, what we currently have is 7K3 that's connected to leaf 101. Okay, and we're setting this as access VLAN 1001. Okay, so if we did a packet capture between 7K3 and the leaf, the traffic is just normal Ethernet. It doesn't have a .1Q encapsulation. Okay, then we're going from the leaf, we're going over to 7K1, and we're trying to do this as a trunk. Since I'm including the same VLAN number on both of the interfaces, this is not a supported config. What I would either need to do is to change the link going to 7K3 to do tagging, so to add the .1Q header, or to untag the port as it's going to 7K1, which means that from the rest of the external layer 2 bridge domain, we would set that to be the native VLAN. Now again, the VLAN number is only link local anyway, so whether we're tagging it or untagging it only makes a difference between the leaf into 7K1. It's just kind of inconvenient that you would assume that you could do both at the same time like you can on Catalyst or standalone NXOS, but Nexus running in ACI mode unfortunately doesn't support that, at least in this particular release. Okay, so what I need to do instead is I'm going to go over to 7K1, and if we show run on interface E17, I'm going to say on interface E17, switch port trunk allowed, or switch port trunk native VLAN is going to be 1001. Okay, and what I'm going to set here instead under the GUI is that it's not going to be trunk encapsulation, it's going to be untagged. Then submit. Okay, hopefully the end result of this should now be that we get connectivity between these two endpoints. Let me make sure the config is saved. Okay, let's go under EBG public web servers, under static bindings, and then node 101 port 1/1, okay, says it's untagged. Let's look at the running config. Show run. And I want to look under the leaf, okay, which is going to be at the port level. So basically the same config between the two of them. Okay, switch port access VLAN 1001, tenant INE, application INE apps, okay, and so on. I may need to just exit out of here. Okay, let's show spanning tree for VLAN 1001. It's forwarding towards that link. Okay, now we have reachability to it. Okay, if we look at from the leaf's point of view, so let's go to the APIC, and we're going to drop to the bash shell. We're going to show fabric membership. Okay, it shows us we have our 3 nodes. We're then going to attach to leaf 101, which is essentially just SSHing to its out-of-band management interface. Or actually, technically this is the in-band management interface. But anyways, it's SSHing to the leaf. And then we log in as admin. And let's look at the show interface status. Okay, so these are our normal Nexus verifications. We should see that port 11 and port 13 have access VLAN 1 assigned onto them. Okay, it's still listed as a trunk, but the switch port config, if we look at the show interface E11 switch port, it should say that the native VLAN is 1001. Native VLAN, well, and again, this is where it gets fuzzy because the VLAN number that the EPG is using does not have to be the same number that it's actually using for the encapsulation on the back end. So what I would need to do here is to look at what is trunking native VLAN 30, and then how is that mapping to the port level encapsulation that's actually being used on the EPG. Essentially here, 30 is just a placeholder on the back end. So if we look at the show VLAN, then I did 2 tabs, so show VLAN tab, I want to show VLAN extended. What this says is that VLAN number 30 is the encapsulation VLAN 1001 at the port level. And what VLAN 1001 is used for is for tenant INE, application profile INE apps, endpoint group public web servers, which has been deployed on the physical ports 1/1 and 1/3. Okay, now let's say we wanted to take this one step further. Let's say we want to extend another VLAN outside of the fabric, but in this case we're going to be doing tagging on both of the ports. Okay, let's say that we're going to be doing VLAN 1002. So what we're now going to do is we're going to take 7K4 and we're going to create a subinterface on its port. Okay, so we're going to create interface E1/15.1002. That's going to be IP address of 10.02.74/24. And then we're going to do trunking from leaf 102 down to 7K1. That's going to be a trunk. And then we're going to have interface VLAN 1002. Okay, this guy will be 10.02.71/24. Okay, so let's go over to 7K4. And let's do our basic port level config, which is going to be on interface E115. And actually, I think those might be backwards in this diagram. Let me see, 15, yeah, 15 should be going to the first leaf. Okay, so 15 is here, 16 is going to the second one. So let's go to port 15. E115, no shot. Interface E115.1002. Interface E115 should be no switch port. Interface E115.1002 is encapsulation .1Q 1002. IP address is 10.02.74/24. And no shot. Okay, if we show LLDP neighbors, we should see, let's turn on LLDP, feature LLDP, show LLDP neighbors. We should see on port 15, show interface status. Port 15 is connected, show LLDP neighbors. Show LLDP interface. What, E115? Okay, transmit and receive, yes. Show LLDP neighbors. Okay, so we have the connection to the leaf. If we show CDP neighbors, though, this should tell us that we don't have the access port policy configured. Okay, so we're going to make a couple edits here. We're now going to go to the, and actually let me do the other 7K as well. So let's go to 7K1. This is going to be on port 8. Okay, so let's go to interface E18. Switch port mode trunk, no shot. Okay, we'll switch port and then switch port mode trunk. Okay, so no special config on this. We then have VLAN 1002. We have interface VLAN 1002. IP address 1002.1002.71/24, no shot. Okay, show spanning tree VLAN 1002. We want to make sure that it's forwarding on that port. Okay, right now it's going through legacy listening and learning. Okay, reason why again is that the ACI is not running spanning tree. Okay, so now we're forwarding. Let's look at the show MAC address table for VLAN 1002. Okay, right now we don't have anything, okay, other than just our local addresses. So we're going to ping to 10.02.74. Count is unlimited. Okay, that's what we're trying to get reachability to. Okay, now on the ACI, we're going to add 1002 to our pool. So we're going to go back to Fabric, Access Policies, Pools, VLAN, Access VLANs. Okay, we're going to add the encapsulation block. We're going to say from VLAN 1002 to VLAN 1002. Okay, this is static allocation. Okay, so now we have an additional range added on there. Okay, next we're going to deploy the policy group onto that interface. So we're going to go under Quick Start, configure an interface port channel and virtual port channel. We're going to say that we have new switch, which is going to be switch 102. We're going to call this Leaf 102 profile. On Leaf 102, we have port 1/1, okay, which is going to 7K1. That's going to be interface selector Leaf 102, 1 ports 1, using interface policy group access ports, okay, access ports policy. Same thing is going to be on port 1/4 on Leaf 101. Okay, so that interface going towards the 7K4. 1/4. So we're going to go to switch 101, configure switch interface. Interface is 1/4, which will be Leaf 101, 1 ports 4. Interface policy group is going to be our access ports policy. Okay, save and submit. If we now go back to the 7Ks and look at the show CDP neighbors, we now see the leaf appear. So we know that the policy group is applied. Okay, we can't yet send traffic there because we don't have the EPG deployed. Okay, now we're going to create a new EPG. So we're going to go under tenants, tenant INE. We're going to create a new bridge domain. Okay, basically a new VLAN essentially. Create a bridge domain. We're going to create BD 1002. This is in VRF INE public. And the layer 3 address is going to be 10.0.2.254/24. Okay, that's our Anycast gateway. And again, we'll set the MAC address to be that custom address. Okay, then next and finish. Okay, next on our application profiles, we're going to create a new EPG. Create application EPG. We'll say that this is going to be our legacy VLAN 1002 servers. Okay, this is going to be inside bridge domain BD 1002. We're then going to deploy the EPG. So EPG legacy VLAN 1002 servers, we're going to deploy this on an interface. Okay, we're applying it on Leaf 101 port 14. Okay, again, Leaf 101 port 14, which is the one that's going over to 7K4. So 14 is going to be using port encapsulation VLAN-1002. Okay, this is going to be a trunk port. We're then also going to deploy it on Leaf 102 port 1. Okay, Leaf 102 port 1 is the link that's going down to 7K1. So port encapsulation VLAN-1002 configured as a trunk. Okay, if we now go back to the CLI, what we should hopefully see is now we have connectivity between the two endpoints. So from the 7K's point of view, from 7K1's point of view, this is just a normal trunk link that's going to any other switch. The main difference is going to be is that the remote box is not running spanning tree. So when we looked at the initial port coming up, and we looked at the show spanning tree for VLAN 1002, originally port 1/8 was in listening mode or learning mode because we had sent a rapid spanning tree synchronization request that we didn't get a response back to. In this particular case, that you're not forwarding traffic through the leaf to other switches. So in the case you don't want to extend spanning tree through, and then the link from your classical Ethernet domain to the leafs should be configured as an edge port from your normal classical Ethernet switch's point of view. Okay, so what I mean by this is that if we were to go to 7K3 and let's ping that destination, okay, we see that it's working. If we go to 7K1 and we go to interface E18 and let's say shut, semicolon, no shut. Okay, so we're just going to flap the port briefly. Okay, that's actually, let's say terminal monitor first. Then shut, no shut. We see the port goes down and up, and then the end result should be show spanning tree VLAN 1002. Let's see, let me shut down the port to the other leaf. And I'm pinging. Okay, so now connectivity is gone. If we look at the show spanning tree for VLAN 1002, okay, the port is forwarding, and did I deploy this on the wrong interface? Let me go back one step. Let me go to the GUI. Legacy VLAN 1002 servers, static binding for paths. 102.1.1, which is correct. Show CDP neighbors is going to leaf 102, port 1.1. Oh, sorry, I was on the wrong box. I should be pinging 10.02.71. Okay, so we can't reach it. If we go over to 7K1, let's do the same thing again. Let's go to interface E18, shut, no shut. We can see now the ping is timing out. Okay, the reason it's timing out is if we look at the show spanning tree interface E18. E18 is in the blocking state. Okay, it's going to go from blocking to learning, and then from learning to forwarding. Okay, reason why is that 7K1 is asking the leaf, hey, do you agree on the root bridge placement? The ACI leaf is just throwing the packet away because it's not running spanning tree. The end result is that the 7K thinks that either one of two things. It's saying that either the box is not running spanning tree, or it's running legacy spanning tree, which means it cannot reply back to the synchronization request. So to be conservative, the backwards compatibility from rapid spanning tree back to legacy spanning tree is that you have to go through the normal listening and learning phases. Or technically they call it just the learning phase now. But if you don't want to do this, then we would configure this as an edge port. Okay, so let's say interface E18, spanning tree port type is edge trunk. We should have connectivity. Now, which I'm not sure why we don't. Show spanning tree VLAN 1002, which is forwarding. So what changed here? Let me look on 7K2. This other guy should have its connections down to the least. I want to make sure I'm not causing a loop. Ports are disabled. Okay, so it's not that guy's fault. Show IP interface brief. Okay, we should be able to ping. Let's show IP ARP. Can we ping 10.02.254? Yes. Can we ping 10.02.74? No. Or no, yeah, we can. Why was it not working? It must have just been converging. Okay, but what we should now see is that if the link flaps, interface E18, shut, no shut. And I think actually this guy might be causing the spanning tree issue. So eventually it's going to come back. We'll talk about convergence later, but there are some other considerations you need to take into account that relates to or how your legacy switches, or not necessarily legacy switches, but your non-ACI switches are interoperating with the leaves. Okay, so again, this example here is what they're calling in the documentation is just extending the EPG. So we're using 7K4 as if it was a server inside of the fabric, and then we have 7K1 as our external trunk towards a switch that has connectivity to whatever the application that was there to begin with. Then the key here is that between the two endpoints, we don't need to apply a contract because they're in the same EPG. By default, devices in the same EPG can talk to each other. Devices in different EPGs cannot unless they have an explicit contract defined. Okay, so like if we were to go to 7K3, which is the box that's in EPG web servers, this guy should be able to ping the gateway 10.01.254. It should be able to ping the gateway for the other bridge domain 10.02.254, but it shouldn't be able to ping 7K1, okay, or 7K3, or 7K4. Like if we went to 7K4, and let's say we have a default route, IP route 0000/0 is via 10.02.254. Okay, that's our gateway, ping 10.02.254. We can reach it. But if we ping 10.01.73, can't reach it. Okay, now we can tell that this is the policy that is causing the failure in connectivity if we were to make one quick change under the VRF globally. So let's do the ping and we'll say count is unlimited. Then what I'm going to do is go back to the ACI or go back to the APIC, and we're going to go under tenants. So tenants, tenant INE, networking, VRF. The VRF is public. This is the name that I gave it. And I'm going to say policy control enforcement preference is unenforced. Okay, then submit the change. The end result of this should now be we do have connectivity. Okay, so let's look at that again. So let's go back to the APIC. And under the VRF, I'm going to say, so VRF public, policy control and enforcement preference is enforced, which is the default. Then submit the change, and the end result is now traffic is dropped. So this again would be if you're trying to implement just your network, if you're trying to implement just your network-centric model, which means that you don't want to use the policy engine in order to filter any of the traffic. Okay, questions up to this point for extending the EPG out of the fabric to another layer 2 network. Okay, there's a question here, was the enforced option for traffic between the EPGs correct? So traffic within the EPG by default is allowed. Traffic between EPGs is denied. Okay, then setting that option that was unenforced. So this was under, again, tenants, the tenant, networking, VRFs, the VRF name, policy control enforcement preference, unenforced or enforced. Okay, default is you are using the policy. Basically, you have access is applied, essentially. Okay, unenforced is saying permit IP any.